Okay. Hi, everyone. Welcome to this working group serving meeting. Remember, this meeting is being recorded and will be published. So please behave and be part of the CNCF code of conduct. So, and with that again, welcome everyone. So let's start with the agenda. I see we have clear on orchestration and DRA. So let's kick it with auto scaling. Ray, are you here?
I think Ray is saying that he'll be missing the first half of the meeting. Like, you see his comment here, right?
Oh, sorry. I had the comments away from my eyes. Okay, so someone is typing on DRA. Maybe can comment while typing.
Yeah, sure, that's me. Basically, we're just executing and defining our caps. There was a cap that this group sponsored in Signode last cycle, and Sergey is doing a update to that to support DRA. I just put the PR in the text there. I'll just put links to the other caps just so people have a reference to them. But just as a sort of status update, we are trying to get the caps done before the deadline. That's all we're doing right now.
And again, I think the priority right now to get into beta, understand what can block beta, and once in beta, we may have more features added. It's just easier when you have something in a more stable state, and then you will gather adoption faster.
Yeah, for sure.
Release fast, release often, as they say. Thank you. So orchestration or multi-host, any champions around?
No update on orchestration. Yeah, I guess updates will be under the sub-project updates in the next section. So I'll defer to the sub-project leads to give an update.
So jumping to Kellen. Do you need to share your screen or something, Kellen?
No, we're okay. Still iterating over the naming. There were some offline concerns with the name we came to on Thursday. So working through that. And then Abdullah has a point. But other than that, not too much.
So I want to say, I wanted to make sure that the justifications and the reasoning for the naming is captured in a doc. So I've been working with Kellen to make sure that the discussions make their way into a doc and the reasoning behind the naming. So hopefully that comment, I guess, Kellen, do we want to, what's the best form? Is that just going to be a Google Doc we'll share, and then we'll integrate a summary of that in the alternative section of the API proposal when we merge?
I think that's fine. Yeah.
Okay. I want to make very, very certain that we capture the reasoning for the naming and have a clear framework just to, because that'll set some boundaries for what is and isn't in the API in the future, because naming is destiny.
That will be captured under the existing proposal, right? That's already merged. The project proposal.
No. This would be covered under the API proposal.
Oh, the API proposal. So, okay, got it.
Yeah. So the API is effectively defining how people think about the project, and the architecture defines how it's implemented to accomplish that. So I just want to make sure that we, the easy one was we have a bunch of reasoning for why we didn't choose different names. Some of them are pretty fundamental decisions, like we think that this project is focused on LLMs to start with, but we know that Gen AI use cases may be relevant. What is our API approach to fields that will be LLM specific in a general API, et cetera? So just trying to get down to that level of crispness before we merge.
Yeah, that makes sense. And perhaps in the future, we can still iterate on those terminologies, and because this field is changing so fast, right? If we extend use cases, right, we want to modify the definition too.
And I would say the API proposal is to get to alpha. Once we're ready to graduate to a beta, we'll have to make the final hard decision on what we should be documenting when we transition to the beta for the API, what evolution will look like, given the proposal. Like in the proposal we talked, we want to be able to iterate very fast without breaking people who've already deployed. And so I think that's why that's as an input to the API. I was going to also ask one extra thing. So this is an orchestration general topic, Jan. We've gotten to the point where we've got a rough API and its applicability and usability from a K-serve perspective. I've been trying to make an argument for or against how different model types would show up. And since K-serve has the most experience with orchestrating that, I'd like to do a follow-up before maybe next week with some folks from K-serve on that. So maybe we do like a small orchestration working session.
Yeah, that sounds good.
How would K-serve use LLM instance gateway?
Yeah, actually, Dan, I don't know if Dan's here. He's not. Okay. Basically, we are working on a proposal or like a doc, basically outlining the ideas of how to integrate instance gateway to K-serve. So that's gonna be in progress. I don't know if it's gonna be a dedicated session or it will be discussed under the same weekly meeting for instance gateway, whichever makes more sense.
Yeah, let's follow up offline.
Yeah, and regarding the algorithm, so we've been running some simulations just to show, like to be able to compare them, the options that we're proposing in the document, to give more meat to discuss. Nothing groundbreaking again, but we just wanted to make sure we have something reasonable like to discuss, not just like high level hand wavy proposal. We've run the simulation. We should be able to share it this week.
Okay, thank you, Abdullah. Jason?
No updates in the serving catalog besides I'm taking a look at Ray's proposal for HPA and giving some feedback.
Thank you. So I think we have reached the open topics. So Kevin, you here?
I think Kevin is out today. So yeah, we can move it to future topic. I can move it, yeah.
Is this tabulation here on purpose? Why this is different from, I don't like, Xianyin, do you want to go ahead?
Jiaxin, are you here? Okay, I guess we can move on.
Yeah, so Nick, do you want to continue the open topic? Or
Nick will be here late. Oh,
yeah, I
I
see
see Nick here. Okay.
But it might be best effort because I'm on kid duty for like the next half an hour.
That's awesome. Okay, thanks. Thank you for joining us. So do you want to share your screen maybe?
Yeah, sure. So what are we looking to do? Do you just want to talk about the Cube AI project a little bit, or do you have, has anyone used it or have any particular questions about it?
I was going to say I'd probably like a quick, like high level overview what you're trying to achieve with it, and maybe like give us kind of the elevator pitch for why we should care, and then maybe we can go into questions, because I certainly kind of have a mental list of questions, but I want to make sure we're not biasing the witness.
Yeah, for sure.
We'd love to hear what you want to solve.
Okay. So in general, the project's goal is to make it very easy to stand up something similar to like OpenAI's platform internally on your Kubernetes cluster. So as a part of that, you know, I'd say the dominant part of that would probably be inference, running inference, especially with LLMs. The other parts that have not been implemented yet would include things like support for vector databases, integrated RAG, things like that, and possibly a small layer of fine tuning. So that's the overall goal of the project, is to make it super easy to operationalize LLMs in the same way that you get if you were to use the OpenAI platform, except you can use that on your own local cluster. Any questions there?
So
is there a
basically,
particular? Oh, go ahead, Jan.
go ahead, Clayton.
I was going to say, is there a particular person who you don't think KubeAI is good for, who wants to operationalize OpenAI's platform? Like, is there any particular user that you don't want to support or serve?
Yeah, great question. I think we'll probably dive into that a little bit more. I think we're going to get into a discussion about probably Kserve. Then I think we can maybe talk about that, like maybe the different target user bases. Does that make sense? So I would say, just in general, like who would want to do this? I would think anyone who, you know, the typical, we want to take advantage of LLMs. We want more than just like LLM inference, but we kind of want to build on top of a base layer of AI building blocks, but we don't want to send our data out. We want to, you know, utilize all our own compute, and everything should stay local in our clusters. So that's the target audience. So in order to achieve that, what the project's main components, I would call, the main component would be an operator, which is acting as an LLM proxy. It's actually acting as a proxy for, we have more than just LLMs at this point. We're looking to cover the general surface area of OpenAI API compatibility. So we support these endpoints at the moment. We look to probably support some additional ones in the future. The proxy is there to serve as I guess a scale from zero, a lightweight scale from zero solution. Trying to think what else we want to cover. So basically you have a controller, it's auto scaling. You're serving backends by scraping their metrics, and it also will buffer and hold requests if there's no backend available to serve the given request. So it's a proxy that would have multiple models and multiple different types of servers on the back end, not too far off from something like what Kserve would do in that sense. I think the general like motto that we're trying to follow is integrate with just about everything and depend on just about nothing. So that's we're trying to make it so that your basic Kubernetes user who does not have a ton of knowledge could just install this and it would work. Let's say like just, you know, one install and it works on GKE, and then you can start running, let's say, you know, the best models on top of TPUs or GPUs or whatever. I'll stop there. I think that's probably enough to give a general picture of the project.
Clayton?
What's the with the ML pipeline and the direct messaging integration? What are some of the patterns that you see? What kind of needs do? Because I would say, like, it sounds like the framing that I have seen others have is there's kind of the OpenAI API support, which is there's a lot of clients that can talk to that easily, and then there's everything else, but everything else tends to be more, you know, queue based or, you know, batchy. are you seeing it like, how would you frame your support for direct messaging integration? What kinds of use cases would you expect people to use most often in that?
The prominent use case it's being used for today is kube-AI deployed into a bunch of GKE clusters in different regions, some centralized pipeline that needs to run through several million documents. And all of those different kube-AI instances are all listening to the same, say, pub sub topic, consuming, and then sending back the inference responses on the other pub sub topic. So that in that sense, they are still using OpenAI compatible API objects. They're just, instead of sending them over HTTP, they're just sending them over, let's say, pub sub in that case.
So that was gonna be my next question was, yeah, like what's the protocol, and do you hit any pain points or frustration points using the OpenAI protocol on the queues, or?
Not so far. The tricky part there is that it's not hyper efficient to do that. What we're doing at the moment is we're saying, give me a topic, we'll listen on that topic, and then as the requests come in, we will, based upon the model specified in the request, we will start to scale up those backends and do inference there. It's tricky in that we don't know how many requests are coming down. Like we don't know the backlog, so we can't make intelligent decisions on scaling up other than just the back pressure that we're seeing off the messages we've pulled off already. And then we also, at the moment, we don't know, we don't currently implement like model specific topics. So we don't know, even if we were to know how many requests are back there, we don't know how many would be for a given model. So that's probably the trickiest part about that integration.
Can you quickly describe the resources that gets created when someone creates a model? So I was looking through the API. I think your API is a model, right? So that's the user-facing API.
Yeah, exactly. So currently we support a single CRD. So here might be an instance of one. We're calling it a model. You could call it a model inference server or something of the sort. The API, so features like this there's kind of a hard-coded different set of features that could be supported, text generation being one. Engine, so there's some hard-coded engines into here, and then you can pass in specific, let's say, VLM flags in this case. All this is pretty standard stuff. I think there's probably parallels in other projects. Resource profile is probably the most interesting thing from a Kubernetes perspective. So we modeled this after SkyPilot. SkyPilot, instead of saying, so SkyPilot, you can kind of say like, I need like, let's say 2 H100s or something of the sort. And then SkyPilot will go and try to find you that, across multiple clouds or multiple regions or whatever. The plan here is to do something kind of similar. So resource profile is defined instead of just specifying, let's say, standard Kubernetes resource requests, for 2 different reasons. One, because the goal is we're going to support multiple resource profiles and then hunt out resource availability, maybe across a single cluster and maybe coordinated across multiple. But the other part of why we do this is that now we can define a model that is, let's just say, like this from a model's perspective. So saying like, hey, I want to run Llama 3.170b instruct. All I need to really know is that I need to run those on H100s. And then depending on where kubeAI is deployed into, this resource profile gets mapped into any number of Kubernetes specific detail. So let's try to So then if you say, okay, well, I need NVIDIA H100s, that maps into something like this. It maps into resource limits and requests, tolerations. And then if you were to install this on GKE, you can then additionally map that in with node selectors. So it's basically a nice, like, kind of.
It's like the flavor in Q as well.
Exactly.
Yeah.
Yeah, so it's kind of like this is going to stay constant across whether or not you're deploying on EKS, GKE, wherever, and then just what backs the implementation details of that would be configured at the cluster level, depending on the cluster that it was deployed into, and the goal is for the. Yeah, go ahead.
Do you create like a deployment and an HPA? Those are like the standard resources that you create, or you don't create?
So yeah, that was kind of a. Okay, we're good. That was an open. So previously, this project was called Lingo, and what Lingo would do, we renamed it at one point in time, roughly around this point. What Lingo did is it was just an LLM proxy that was OpenAI compatible, and it would just act as an autoscaler of a backend deployment object. What kubeAI does is kubeAI, the model resource that you see there is the parent resource, and then kubeAI directly manages the pods. So there's no HPA, there's no deployment, there's no replica set. In kind of following with that design philosophy, there is duplication, but there's not a lot in between. There's not a lot that you have to worry about. So, for instance, if I were to deploy this into and rely upon the standard way of doing things with an HPA and custom metrics, there's a good amount of cluster configuration that would be needed in order to do that. And we decided to actually just scrape the metrics directly and then manage the pods directly. We got a question.
Yeah. Hey, this is Apurva here from AWS. Is there any kind of governance model around which model can be used or allowed in like a particular organization? For example, I don't want somebody to use like a Llama 3.1B for 405 billion parameter model or something like that.
No, anything that would be, I guess, related to what do you want to allow within a given organization would probably be dictated by who is given Kubernetes RBAC privileges against the model objects themselves.
I see. Okay, thanks.
Yeah, so then I guess maybe a follow-up question might be, why do you manage pods directly? Why do you not use things like, let's say, deployments or replica sets or something of the sort? There's a few different reasons why we went that route. One of them is that one of the goals is to manage, is to also be aware of like state that gets attached to those pods as they come up. So the target use case for that would be to dynamically manage LoRa adapters for serving against maybe a large model that's just kind of sitting there and running, and being aware of the state of a given pod mapped to what LoRa adapters we've already loaded, and then being able to make routing aware requests based on what's already loaded to different pods and what do we need to load at inference time. That's kind of part of it. I think that that'll be a little bit easier to do by managing pods directly. The other part of it is that if you look at projects like SkyPilot, I think they're gaining traction because they can search out capacity in a space where we're typically capacity constrained. If it comes to I need an A100 or whatever, it's kind of hard to come by. operating at the pod level, the goal is to respond to moments when a given pod can't be scheduled. Maybe let's say node auto provisioning has been unable to find the capacity on that cluster. Or let's say that just the cluster autoscaler is enabled, you don't have auto provisioning. And you're kind of, I want to be able to kind of accept feedback, see that pod's not gonna be able to be scheduled in a reasonable amount of time, delete the pod and recreate the pod as a secondary resource profile. So let's say that for Llama, 3.1 70B or whatever, I have different configurations defined depending on whether or not it's running on H100s or something else. I want to be able to detect H100s are out of capacity. Let me go switch over to something else, and that's actually going to require a pod recreation. So there's like some clouds, like let's say GKE have the concept of things like, what is it, compute class, I think, where you could specify a pod, and then that you can kind of have a roughly, you can underspecify what it needs, and then you can say it just needs this class, and then that class can be backed by different resources. I don't think that that's going to work for all these cases, because if I'm running a given model on this GPU A, I actually need to pass different parameters to the backend serving instance, let's say VLM, as opposed to if I'm running that model on a different set of accelerators. So it's not that I can just say one pod can get backed by any of these given, let's say, compute classes, but instead I actually probably need to delete and recreate the pods. So with all of that in mind, there's a lot of like pod awareness, pod state that's going to be tracked. We made the design decision to actually just manage pods directly and say, hey, we're gonna eventually eat all the complexity that's going to come along with scaling and eventual consistency and counting replicas and things like that. I don't know, that's I think the more interesting stuff to talk about. Any questions or thoughts on that?
I was gonna, yeah, this may not be directly related. I was gonna ask, when you're doing queuing for scale to 0, are you doing anything specific to mitigate the long startup times? Like how, because like scale to 0, obviously, if you have to go wait for a whole VM and for startup, anything you're doing that you feel is important or would be more generally valuable, or things that you've been blocked by doing in the startup space and startup time space?
Yeah, this is currently a pain point, obviously. So if I'm trying to spin up some massive model, and obviously scale to 0, the whole part of the goal here is that we can turn off these expensive GPUs. So let's just assume cold start on the nodes themselves. Obviously, there's a lot of large stuff that needs to get loaded onto that node, right? The containers for these Python projects are not exactly small. I'm getting given just a bunch of GIFs over here. So those containers take a while, and then the models take a while because they're also large. So there's different layers of caching, I think, that's going to make scale from 0 a little bit more attractive. Obviously, things like, let's say, GKE, where you can preload images on a secondary boot disk, that's going to come into play. And then also, let's say, things like being able to load in your models off of a cache, maybe backed by some disk or something of the sort, is going to come into play to mitigate that. But scale from 0 is not, I mean, in production, if you're serving inference requests, I doubt that you're going to be scaling to 0 for most of these things. My guess is that most organizations are going to want scale from 0 for a whole lot of internal use cases that are okay with that startup latency because of all those cold starts that are happening. And that is where you might have, let's say, like a research team that might want access to a whole bunch of different models for running maybe different experiments or whatever they're doing. And they're okay with taking, let's say, 10 minutes for the thing to spin up. Although I think we can get that down significantly to where it's a lot more palatable. I think we got a question.
Yeah, so on the topic of like loading models quickly, right? Something I've been thinking in the back of my mind is, what if we decouple images from pods and manage like artifact and image lifecycle separately from pods? So that way we can declaratively preload them on the nodes. I mean, we have something with pinned image set, but it's maybe not enough.
Decouple images from pods?
Yeah, like the life cycle of images from the life cycle of pods and containers, right? So I can say, oh, okay, on these set of nodes, I want to preload Llama and other models. And then there's GC running on it, of course. Clayton, I'm not sure if that's ever come up in the past.
I got completely distracted, so I can't answer your question, sorry.
All right,
Yeah, I think
no
it goes to something we discussed in the past, that is caching. So that has been discussed when we were running like dual meetings, so working group and work stream meetings aside. So in one of the work stream meetings, we discussed caching and how to preload images on nodes when we were doing like a scale up scenario, right? So that was discussed. And
yeah, I
just to
think
provide.
right. I feel like there are like many different ways and many things people are doing. Like you have something running all the while just to keep an image pinned, or you can potentially use the new pinned image API that we added to the CRI. But if we're just first class in Kubernetes, maybe it just makes it easier.
Like we've had the schedule. So like there's like the scheduler has a very, I want to call it hacky optimization that we put in. I think it was in like 1.0 or 1.1, right? Where we try to pick nodes that have the exact image. And the problem is exact image isn't defined in Kube. So like, if you hit a tag and you end up needing to pull it, the cache doesn't help, but it works okay. I think kind of what you're alluding to, Mernal, is like, is there something that we could do that would help the performance of big images or things that need to download a stuff where we could make better scheduling decisions, and or on either side of that, make better schedulings based on data we have, or make it easier to get data off the nodes to signal to scheduling it. I think this is we didn't really finish the caching discussion, so it's kind of I like that aspect of the work stream where we could just go spend an hour and really like dive in. I feel like we do really need somebody to like organize this on the caching side and really drive a discussion. We've got a lot of topics we kind of need to convert them into action, or convert them into a concrete series of recommendations that would really benefit, a class of users.
We have a question, Dave?
Yeah, I was going to point out that when you want to do caching, you want to cache the image by digest. So essentially, this is kind of the thing we do in Knative, where anytime you create like a revision, we do this digest resolution. We stamp out a revision, and we also stamp out a CRD that is not technically implemented anywhere in like the open source of this caching resource with a specific image and like some pull secrets. So in theory, like a simple CRD like that can be used to be pluggable in these caching mechanisms. I think what's important is like you have to cache by digest. Otherwise you have no idea where you're caching.
Sergey?
I want to go back to Nick and ask a kind of general question. I know you said that you use a lot of primitives. I mean, you don't use too many higher level primitives to control pods and stuff like that. Do you have any wish list of what underlying pods needs to implement to do stuff better for you? Any like wish list that you have, or something that you discovered that can improve your kubeAI better?
A wish list of functionality of, let's say, like your standard Kubernetes resources, like the functionality they might implement.
Yeah, maybe pod lifecycle can be improved in certain ways or stuff like that.
I don't off the top of my head. I think of some of it was more of an intuition in that I believe we're going to have a lot of pod specific awareness that's going to be built into this thing. And so I thought it would be easier to kind of two different reasons why we went direct pod is that I think because of that, I think it's over time going to be easier to manage pods directly. I think there's some interesting things where if you look at like, let's say like managing an ASG or something like that, right? One of the techniques I could use to scale down the ASG is to say, I no longer want this specific instance, and I want to decrement the desired instances by targeting the specific instance. I think you have parallels on at least GCP. I don't know if that's available in things like replica set or deployment. I don't think so. I feel like that could be interesting functionality. We don't need it at the moment, so I'm not saying like that would be, that would be a great feature that we must have, but I can see that being an interesting thing to have where let's say that you detect some additional capacity and you want to turn down a more expensive accelerator or a pod that's running on a more expensive accelerator. So being able to specifically turn that one off and turn another one on could be interesting. The short answer is no.
Yeah, it's a good sign that everything is there, right?
I would also say like one of the goals of managing, I think there's a big why around why manage pods directly. One of the goals of doing that is that the target user should not, I guess there's a lot of anti-patterns here. The target user, in my opinion, should not have to, a lot of the complexity I've seen in Kubernetes is that because there are these different layers, you have to know about these different layers when things go wrong. So in other words, if I'm managing, let's say, a deployment, which is managing replica sets, which is managing pods, sometimes it becomes difficult to kind of chase down those layers and propagate information that might be at one layer back up to the user in some nice manner, especially thinking around like out of capacity stuff. So I think managing pods directly, you can get all that. You're already like kind of at that layer in which you can receive most of that information and bubble it back up to the user or take action on it. So I think that even if we were to integrate or to implement this, via one of these higher level APIs, I still think that we would probably end up doing a lot of operating at the pod level, but maybe just delegating some of the like the replica computation and pod lifecycle management to those higher layers. I don't know if that makes sense.
Dave, you're first.
Yeah, just a quick question about kind of like the cold start. And this is me being a bit naive because you're mentioning spinning up nodes with those H10, H100s. Are GPUs detachable from nodes? or like can it behave like a disk where you can attach and detach, or does it have to be bound to a node?
That'd be pretty cool. I've never seen that before.
I actually got that question last week, and the attachable GPUs that exist are for gaming in case your laptop doesn't have a GPU. But for production use cases like AWS or Google or things like that, they are not going to provide you detachable GPUs.
So is it?
Yeah, at one of the KubeCons there were some presentations on that. That's a potential future technology. I don't think it's something available to these days. Like you can have a PCI switch, right? You can do that, but I don't think it's productionized anywhere.
I see. So essentially, it's like disks are easy because they're essentially over network, but versus GPUs, you want the high throughput of a PCI. Is that the?
Yeah, you got 3 or 4 orders more throughput you'd have to funnel through for a GPU. So you either are working at that higher level, like gaming, you send display list pixels and you're sourcing data. Yeah. Whereas with AI, a lot of times you're shuttling a lot of data back and forth over the PCI Express bus. And actually, people are starting to shuffle even more of that data over PCIe. So not every use case would work optimally with it. But yeah, people are. I certainly have seen a number of people talking about effectively remote PCIe for a use case, and I think there'll be some use cases for it in the future.
Cool. That's all I have.
Yuan? I think I saw Ray hand raise it, but I think he unraised it. So Yuan, you're next.
Yeah, I just see a lot of, first of all, thank you, Nick, for giving the presentation, introducing the project. I think the reason why we got in touch was that you first shared the proposal to your model cache optimization, right? So I imagine there will be more hacky optimization around pods specifically, or similar efforts to what this working group is trying to solve. I wonder how we can work together in those different problems.
Yeah, I think it's a good question. I think it'd be great to find those areas. In general, I think another good question was, hey, what's your wish list of lower level APIs, or I mean high level APIs? Whether or not those are custom resources or built in. I'll definitely try to maintain a list of those things. The other question is, how do we collaborate with existing projects? And so obviously, there's an initiative with Kserve for model caching. We also, I read the proposal. I think there's some good ideas in there. We also have another proposal that's very similar and references that one.
Yep.
How do we not duplicate effort? I don't really know the answer, and I think this kind of segues into why some of these design decisions, or why a different project. I think that there are two distinct groups of users. There's a group that talks about things like service mesh every year with their engineering teams, and then there's a group that actually is going to run service mesh. And so I think that kind of like when we were first saying, hey, is this project even needed, and is Kserve maybe let's say inference is a big part of this project, right? Should inference be implemented with something like Kserve? The main reason we didn't go that route is because we want a project that's going to serve that other group, that group that's probably never going to adopt service mesh, or if they did and their hand was forced to do it, that they would probably adopt it in a way that's they installed it, but they're not really sure what's happening if it breaks. And so that's kind of the target audience for this project, as opposed to if we were to rely upon stuff like that. And then that's also I'll keep on talking for just a second, and then I want to hear your take. The more if you don't take that approach up front, I think the project gets to a place where like you're almost in dependency hell, because let's say that now we want to support distributed VLM serving. Well, now we need Ray, right? Well, do we now also depend upon the Ray operator to get there? Do we also, now we're at what? K-serve, Knative, Istio, Ray operator, and that's just inferencing. And so if you think about the OpenAI platform as a whole, like if that's kind of like the target, right? Inferencing is just a part of that. And so that dependency, if you take that approach, that the list of dependencies gets to the point where your average Kubernetes user is just not, or average Kubernetes admin is probably just not going to be able to tackle that or maintain it. And that's why we've kind of taken this hard approach of, copy over depend on, and kind of incurred some of those costs along the way.
Got it.
I'd love to hear your opinion on it, though.
Yeah, I did mention the possibility of using the raw deployment mode from Kserve, which reduces the dependencies, especially the ones you mentioned. And I also imagine like that you spend a lot of effort building multi-host solution as well, especially that you are managing pods directly. There will be a lot of complexity and information that's buried in those pods that you need to surface to the end user. So yeah, if it would be great to hear your feedback on the raw deployment mode, if you can ever try it out, and let us know any gaps that we can help you, if that's still a direction that you can research into.
So raw deployment mode, basically you're saying, hey, you get everything that you get with, let's say, if you were to go the Knative route, except you can't go all the way to 0. Would that be accurate to say? Or I guess you're missing some other things too, right? Like some advanced rollout techniques and things like that.
Yeah, there are some feature gaps for sure. So that's why I'd love to hear like whether there's a list of features that you require, and what are the features that are optional, so that we can start like leveraging what we have. Yeah.
I think it would maybe come back to, I guess by default, like if you were to just take the quick start of Kserve, I think that you wind up with something like close to 40 CRDs in your cluster. And the end user might not be exposed to the complexity of all those different resources, but it's there, and it might bite them when it comes time to upgrade, or if they're, if they're even sharing this cluster with something else that maybe depends on a different version or something of the sort. I just, at some point, I think there's going to be complexity, right? There's going to be either complexity in your project to manage pods directly, or there's going to be complexity that is exposed to end user as a large API surface area that they need to be concerned with, and the compatibility across those different things. I've just seen that second part of the complexity bite so many teams and kind of become a deal breaker for so many teams that I think that there is a valid. I think the community would do well with a valid second option. So like an option that is more fully integrated. But with that said, I think the original question that we had too was, hey, what users are not well served by this project? I think a team that would say like, hey, it's that other group that we already have service mesh, we already have Istio, we have our life cycle management of all those components and configuration already built in. You're fully set up in that sense, I think, for just layering on kserve and perhaps knative if it's not already there, which I would assume it would be. I think those users, like those powerhouse users, I think are I would probably recommend them go towards the kserve route. In my mind, if I'm thinking of like, hey, user mapping one to which project. But I think the second that we start depending upon a bunch of other projects for those core things, I think it'll introduce more complexity than it might take away.
Mm-hmm.
Overall.
Yeah, these are really valid points. Thank you for sharing that. If you can, I think going forward, if you can create, like you said, a wish list of features that this group might be helpful with, please do share once you have that list, and we'll try to help as much as we can.
Yeah, it sounds good, and I'd love to get more involved in this working group and collaborate as much as possible. If it's just designs and kind of let's say from model caching perspective, let's make sure that we align on designs that make sense and consider the trade-off. I think that's a big win. If there's shared components that are not a exposed complexity to the end user, I think that's also a win. So any sort of, I guess that would probably be at the Go library level. I think it's really just at the API server dependency level that we're trying to avoid dependency. So we don't really want the end user to have to worry about compatibility across those different projects.
Mm-hmm. All right, thanks, Nick. Thank you for making the time to present.
Yeah, thank you, everyone.
Thank you. Joan, you're the last one in the agenda. You have 3 seconds.
Sure. I'll take 20 seconds. Is Ashok here by any chance?
Hey, yeah, I'm here.
Yeah, so I'm just wondering if there's any update on the benchmarking tool discussion. Have you been in touch with the SIG scalability and VLM community yet?
Yeah, so I'm following up with a couple of VLM folks. I've shared the doc and I've asked for some feedback. I think the main point to kind of finalize there is benchmark as code versus benchmark as tool.
Mm-hmm.
And I also looked at cluster loader to see what is there currently. I'll reach out with some scalability folks there too.
Okay.
I feel like cluster loader isn't a great fit from the looks of it so far, but I'll check with them. And
Okay.
got some feedback from someone on Red Hat about a Vegeta-based tool that they are using, which looked interesting.
Yeah, so we'll be so our team from IBM and Red Hat will be presenting an existing tool that we built. It's open source. Hopefully we can share more next week, and hopefully we can, like, if possible.
Yeah, it would be good to once you share that, it would be good to know how it works and all that. And I would also like us to schedule like a benchmarking sync for people interested in discussing this further. It would be good to kind of settle on one of the approaches and kind of figure out what are the specific things we need to solve. And then, pick the tool.
Yeah, can you add me to that meeting so that I can loop in the relevant folks from our team?
Okay. Do you want me to schedule it? And I was also wondering who all wants to be part of it.
Yeah, we can discuss offline, but maybe in this meeting, as part of this meeting, is there anyone else who's also interested in that discussion? Okay, I haven't raised hand. Okay, maybe we can start a thread in the Slack working group Slack channel and then see whoever is interested can be added to that meeting.
Okay, that sounds good.
All right, that's it. Took over 20 seconds, but thanks.
Thank you, everyone. So we are on time. So I'm closing the recording. Thank you, everyone, and see you the next week.
Thank you.
Thanks.